So we're going to continue that journey of simplifying expressions with exponents in it. And we're really just going to build on what we've learned for the most part, and then we're going to have something that I like to call a battle. So when we have bases that are the same on the top and bottom of a fraction, it's like a battle. To divide powers having the same base, subtract the exponents. And it has to be the top exponent minus the bottom exponent. So it has to be m minus n in this case. And here in this example, it has to be 7 minus 4 in that order. 7 minus 4 is positive 3. So here we have numbers with the same, the bases are numbers. The base is 3. So it would be 3 to the power of, well, I'm thinking to myself, 4 minus 3. Oops, 4 minus 3 is 1. So it's 3 to the 1, which really just equals 3. Here, my base is 3, and then 6 minus 6 is 0, which is just 1. Now, what's interesting on that, so if you're not believing what we're doing here right now, or you're wondering why, you could have taken this 3 to the 6th and calculated it. It's 729 on top, and then 3 to the 6 is on bottom. That's 729. Remember, anything divided by itself equals 1. So that should hopefully kind of like prove what we talked about yesterday with the fact that anything raised to the 0 power is 1. It really just means you're dividing it by itself. So here we have x to the third. Well, these go pretty quick and pretty easy. We're just doing subtraction. It's like second grading it. Well, here we need to bring back some of our properties. Now, these are in the same side of the fraction bar, and they have the same base, so we can add the exponent. So that's 5 to the 6th on top, divided by 5 to the 3rd. Well, now it looks like these. Now we have bases on the top, the same base on the top and bottom, so we subtract the exponent, so we get 5 to the 3rd. Let's take a look at this. Now, notice here, we have the same bases on the top and the bottom, so we could subtract it, but we have to take 3 minus 5. We have to take the top exponent minus the bottom exponent, which is a to the negative 2. Let's leave that for a second. That's not a good final answer. That's not in simplest form yet. Let me expand these. On top, we have a times itself 3 times. On the bottom, we have a times itself 5 times. Ooh, let's clean this up a little bit. So we have these common factors that get canceled out. Really, remember, anything divided by itself is 1. So essentially, I have 1, 1, 1 times a on the bottom. So on the bottom, I actually have a squared here. On the top, I have nothing. Remember, when we talk about multiplication and division and there's nothing there, we have to put a 1. Hopefully this reminds you of yesterday. When we had these negative exponents, we need to move them to the other side of the fraction bar. Well, right now it's on top of the invisible divided by 1 fraction. So now it needs to move to the bottom, and the exponent becomes positive. So a to the negative 2 on top becomes a squared, a to the positive 2 on the bottom. Same thing over here. We'd have 5 7s on top and 7 7s on the bottom. 5 of them would cancel. It would leave 7 times 7 on the bottom, or 7 squared. On top, there's nothing, but because it's multiplication and division, we have to put a 1 there. So 1 divided by 7 squared. Our final answer, I didn't mean to circle this one right here. It looks like it's our final answer or something. Our final answers never have a negative exponent. So you could have thought, well, this is the same as 7 to the negative 2, but it needs to get dropped down to the bottom. Final answers never have negative exponents. So this is a new big idea, that when we have bases on the top, the same base on the top and bottom, we can just subtract the exponents. This shouldn't be too shocking right here. When we have an exponent outside the parentheses, we need to sprinkle it, as I say, to everything in the parentheses, even if there's something on the bottom. So we've done this before, but now that exponent of 3 also needs to go to the y on the bottom. Let's try that a little bit. So here we are sprinkling the exponent of 2 to everything in the parentheses. So we get x to the power of 6 on top, 3 to the power of 2 on the bottom, and y to the power of 8. Hopefully this bothers you a little bit, because 3 squared is 9. So the best answer is going to look just like this, except for we have 9 y to the 8th. Let's get in the habit of doing that. On your assessments, I want you to do this. I need you to do it. On your practice, it'd be good to get in that habit. If it's a big, nasty base and exponent, you don't have a calculator, not the end of the world if you don't do that. But if you have a calculator handy, or on your test, you will have a calculator handy, so do that, please. So here we get sprinkling. We get a to the 6th, b to the negative 2 times 2 is negative 4, 3 to the power of 2, c to the power of 6. Now remember, we can't have a negative exponent in our final answer, so this is going to be the same as, here we have a negative exponent right there. I think of that as a traitor. It's supposed to go down to the bottom, or on the other side of the fraction bar. So we have 9 b to the 4th. Once you move it, make the exponent become positive, c to the 6th. On the top we have a to the 6th. Final answer. Sprinkling. Let's change colors up a little bit. Sprinkling. 3 sprinkles on top, 3 sprinkles on the bottom. Oop. And there. So we have 16. I just calculated 4 squared. A to the 9, b to the negative 4, 2 to the 3rd squared. That's the same as 2 to the 5th, which is 64. You could have thought of this as 8. This 2 to the 3rd is 8. 8 squared is 64. A to the 4, b to the 6th. Now we need to simplify this. So first look for any traitors. Here is a traitor. It's on the top, but it's a negative exponent, so it needs to go to the other side of the fraction bar. Actually, it needs to go to the bottom. So on the top, we actually just have 16 a to the 6th. Oh man, did y'all catch my mistake? Right there, Mr. P. When we have a power to a power, we multiply them. So that's a to the 6th. Oh, Bessie, my bad. Sorry about that. So on top we have a to the 6th. On the bottom we've got 64, a to the 4th, b to the 6th. I'm using this b right here. B to the 6th. And then remember we had this traitor on top. This b to the negative 4. It's on top. It needs to move to the bottom, and then you make the exponent positive. So b to the 4. So we're not done simplifying this yet, folks. There's actually 3 spots that we need to simplify. These b's are on the same side of the fraction bar. They're buddies. They get combined. When we're multiplying the same bases, we add the exponents. So that will be b to the 10th. Here, we have the same base on the opposite side of the fraction bar. I think of this as a battle. I got 6 a's on top being multiplied together, 4 a's on the bottom being multiplied together. The top is going to win by 2. So it'll be a squared on the top. And then last but not least, we can simplify some numbers here. 16 divided by 64, we can simplify to 1/4. So let's go through that again from left to right now. 16 over 64 is 1/4. Now if there's anything else that gets left up here, we can get rid of that 1. a to the 6th divided by a to the 4th. We subtract the exponents. The top wins, so it's a squared on top. These guys are buddies. Really, we have 6 b's getting multiplied together and 4 b's getting multiplied together on the bottom. So together, that's 10 b's being multiplied together, b to the power of 10. We can erase that 1. We don't need the 1 there. It's not wrong to have up there. Anytime we see a variable without a value in front of it, we can slip a 1 there, but we don't need it. So whether or not you have that 1, it means the same thing. Final answer right there. Twice, yes. Okay. So, folks, that's it. That's it as far as rules go. Now, can we apply them in some of the bigger, nastier type problems that we could see, or challenges? Think of these as challenges. Here's a 6-step process for things to look at. Remember, if you see a power, anything raised to the 0 power is 1. We have that power rule where we do sprinkling. Whether it's the top or the bottom, sprinkle, sprinkle, sprinkle. Get that sprinkling done. Then if we have traders or negative exponents, we take care of that. Then if we have the same bases, we're going to combine the teammates. So we're going to identify any bases that are the same and combine them together, add forces. And then we go to battle. If they're the same bases on the top and on the bottom, we subtract, or we see who wins that battle. Who has more? Compare the exponents. And then if you can simplify the numbers out in front, the coefficients, do that. So here we go. I see no exponent of 0. I see no sprinkling or power rule. I don't see any negative exponents. I do see some bases that are the same on the same side of the fraction bar. What I mean there is I see x squared and x to the 1. That is x to the 3rd. We add the exponents. And I see a y to the 1 and a y squared. That's y to the 3. And I see a 2 times 9. That's 18. On the bottom, I see a 3 times a 1. Or I'm just bringing along that 3. I see an x, and I see a y to the 4. Oops. So I just took and combined anything using the product rule that I could, combining the bases that are on the same side of the fraction bar. Now we go to battle. So now there's a battle between the x's. 3 minus 1 is 2. So the top one, so the top gets an exponent of 2 with the x's. Now with the y's, which side has more y's? The bottom. You could do subtracting, you can get y to the negative 1 on top. Well, y to the negative 1 really just drops down to y to the 1 on the bottom. Or the way I like to think of it is these are battling, the y's on the bottom win. So there are y's on the bottom. How many? There's one more left there, so y to the 1. But we actually don't need to write that 1. And then let's simplify 18 divided by 3. 18 divided by 3 is 6. That was fun.